This is Arvin Vora, founder of Vora Method and author of The Equation for Excellence, How to Make Your Child Excel at Math. This video is going to be about the importance of doing nothing. Sometimes what you need to do in math is nothing. Sometimes you need to do something. And so the first few questions here are going to be the easy ones where you're going to actually have to do something. And then later on, we're going to talk about doing nothing. The topic here is called combining like terms. And the basic idea is you have some things that are like terms, some things that are unlike terms. When you have like terms, you combine them. When you have unlike terms, you do nothing. And doing nothing is one of the toughest things to do in math. Trust me on this. The most common mistakes that I see from students in math is not when they don't do something they should do. The most common mistakes are when students do something that they shouldn't do. Let's start off with some easy ones here. These first few ones, you're actually going to do something. If you have a dog plus another dog, you have two dogs, or as we write in math, just two dog. Let's look at something with variables. If you have m plus m, it's the same basic idea. You get m plus m equals 2m. If you have something more complicated, a term like mn plus another mn, you're going to get the same basic thing. You get 2mn. What about with m squared plus another m squared? Well, it's actually going to be pretty similar. M squared plus m squared is going to be 2m squared. Now here's where things get tricky. You look at this, you see m, and you are adding that to that m, you're adding n. Well, m and n are different. And here's where people freak out. They say, okay, maybe I need to... No. If the terms of the two things being added are fundamentally different, they're different things, then the thing to do here, and this is the really hard thing in math, the thing to do is nothing. m plus n equals m plus n. It doesn't change at all. Let's look at another one. The first term here is mn, and the second term is n. And again, you have to say, well, are these like terms? No, they're different. They're different types of terms. So when the term types are different, you do nothing. Again, that's the hard thing in math, is to actually do nothing. mn plus n, it's just mn plus n is not any different. Nothing changes. It just stays exactly the same. Now here's something that's interesting. You have m squared plus m to the third, or m to the second plus m to the third. Or you could say m squared plus m cubed, however you want to say it. Let's say we have m squared plus m to the third. Are these two things, are m squared and m to the third like, or are they unlike? Well, as it turns out, if the exponents are different, these numbers here are the exponents, if the exponents are different, they're considered unlike terms. And what do you do when you have unlike terms? You do nothing. You do nothing at all. Nothing changes. M squared plus m to the third, that's just m squared plus m to the third. Nothing at all changes. Now here's something. Here are two terms. The first term is m squared n. The second term is m squared n. And these terms are complicated, but they're the same. They're the same. See, if you have m squared n plus another m squared n, guess what you get? You have two m squared n's. Just like if you have dog plus another dog, you have two dogs. If you have an m squared n plus an m squared n, you have two m squared n. Now for this one, you need to be really careful. You got to focus on these ones. Here we have mn squared. So here, the squared, the n is being squared. See, that 2 is going with the n. For the next one, this is m squared n. Here, the m is being squared. Are these like terms? In other words, the exact same structure? No, of course not. One has the n being squared. The other one has the m being squared. They're totally different things. They're unlike terms. And what do we do when we have unlike terms? We need to be super intense, super disciplined, and do nothing. Mn squared plus m squared n. It's just mn squared plus m squared n. Nothing changes. What you need to do, and what great mathematicians do in this situation, what they know to do is sometimes the correct thing to do is to do absolutely nothing. And that's what you do in this situation. Well, what about this? Well, this is 3mn plus 4mn. Well, this is like having 3 dogs plus 4 dogs. That would get you 7 dogs. And the same thing here. These numbers here, these numbers in front, these are the coefficients. The coefficients can be different. That doesn't matter. The only thing that needs to be the same is the bases and the exponents. And well, here there's the only exponent is 1, or there's not really an exponent that you can see. So 3mn plus 4mn It's actually going to change. That's 7mn. Why? Because the mn part is the same. The terms, these are called like terms. But what if you have something like this? You have 3mn plus 4mn squared. Well, this is like 3 dogs plus 4 cats. If you had 3 dogs plus 4 cats, what would you have? You just have 3 dogs plus 4 cats. That's it. They don't combine into a single thing. You don't get a cat dog. That's not a real thing. You get 3, and the same thing will happen here. If you have 3mn plus 4mn squared, those are different types of things. And so what do you do when you have different types of things? That's right. You do nothing. 3mn plus 4mn squared just equals 3mn plus 4mn squared. Now, you're going to get a bunch of practice with this, and you might make occasional mistakes, but the key thing here is to learn to recognize terms that are different. And when the terms are different, you just don't do anything at all. You have the active discipline to actively do nothing. And of course, if the terms are like, well, that's the easy one. That's where you actually just add them together, which is about as difficult as doing 2 apples plus 3 apples equals 5 apples. But when they're different, that's the tricky part. When they're different, don't do anything at all, and you're going to avoid some of the most common mistakes that people make in math.